So, in this session, we are going to discuss on the topic of frequency spectrum, which is one of the most fundamental topic and important topic that we have to know while studying about the RF circuit design. So, before getting deep into the topic, we must first know what is meant by frequency. So, frequency tells us how many times a signal repeats in 1 second, and it is generally measured in hertz. If I say the signal is having the frequency of 1 hertz, which means it undergoes only one cycle per second. And for example, if I say the frequency of the signal is 1 kilohertz, it means that the signal will undergo 1000 cycle per second. Just think of a swing which we used to play. Swinging once every second means it is 1 hertz. Swinging 100 times every second means the signal is having the frequency of 100 hertz. So electrical signal also behaves in the same way. Okay. So different electronic systems operates at different frequencies. For example, if we take a power line, it uses the frequency of 50 hertz. And AM radio will use around 1 megahertz. And the common thing which we use, the Wi-Fi, will use the frequency of 2.4 gigahertz and 5 gigahertz. Since there are billions of frequencies which is available in the environment, engineers divide them into frequency bands for which is making it easier for study and also for communication thing also. Okay. So while we are talking about the frequency spectrum is the complete range of the electromagnetic frequencies which is arranged from the lowest to its highest frequency range. Just imagine a ruler which is divided into centimeters. The frequency spectrum is divided into different frequency band. And obviously, we need a standard in order to divide these bands, right? So, that standardizing organization is the IEEE, which is nothing but the Institute of Electrical and Electronic Engineers, who standardize these bands. So, while we are talking about the term frequency, we should also know what is meant by wavelength. So, there is actually a relationship between the frequency and wavelength, which is nothing but it is inversely proportional. In case of mathematical equation, we can say it as lambda is equal to c by f, where lambda is the wavelength in meters, c is speed of light, which is 3 into 10 to the power of 8 meter per second, and f is nothing but the frequency. So, by using this relation, we can see it evidently that whenever the frequency increases, the wavelength decreases, and whenever the wavelength increases, the frequency will decrease. So, since you are looking into this video, you can try various frequencies, which is, for example, try a frequency of 30 hertz and 30 gigahertz and calculate the wavelength. So the wavelength will be around 10,000 kilometer for 30 hertz and 1 centimeter for 30 gigahertz. By this relation, we can easily prove that whenever the frequency is small, the wavelength will be larger, and whenever the frequency is large, the wavelength will be smaller. Okay. So now we are going to look into different frequency bands and what is the frequency range for that band and what is the application that uses these frequencies. The first comes the extremely low frequency between the range of 30 to 300 Hz, which is mainly used for applications like power transmission, underground communication, and submarine communication. Next comes the voice frequency, which is between 300 to 3000 Hz, which is used for human speech and telephone systems. And the third band which we commonly use is the very low frequency, which is between 3 to 30 kilohertz, and it is used for applications like navigation and submarine communication. The next frequency band is low frequency, which is between 30 to 300 kilohertz, which is used for applications like navigation beacons and long distance communication. And the next frequency is medium frequency, which is between 300 to 3000 kilohertz, and it is used for applications like AM radio broadcasting. And next one is the high frequency, which is between 3 to 30 megahertz, and it is used for applications like shortwave radio, armature radio, and military communication. Next frequency band is very high frequency, which is between 30 to 300 megahertz, and it is used for applications like FM radio, television broadcasting, and aircraft communication. And the next frequency band is ultra high frequency, which is between 300 to 3000 megahertz, and it is used for applications like mobile phone, GPS, Wi-Fi, television, and Bluetooth. And next is the super high frequency, which is between 3 to 30 gigahertz, and it is used for applications like radar, microwave communication, and satellite communication. And the last and final frequency band is the 30 to 300 gigahertz, which is used for applications like 5G, millimeter wave radar, advanced imaging, and scientific researches. Now we are getting into the microwave frequency band. So the microwave frequency band can be further divided into super high frequency and extremely high frequency regions into smaller bands. The first band which we are going to discuss is the P band, which is between 0.23 to 1 gigahertz, which is used for applications like radar and remote sensing. The next band is L band, which is between 1 to 2 gigahertz, which is used for applications like GPS, satellite communication, and mobile communication. The next band is S band, which is between 2 to 4 gigahertz, which we use in most of our applications like weather, radar, and Wi-Fi applications, and microwave ovens. The next frequency band is the C band, which is between 4 to 8 gigahertz, and it is used for applications like satellite TV and weather radar. Next frequency band is X band, which is between 8 to 12.5 gigahertz, and it is used for applications like military radar, marine radar, and weather radar. Next is Ku band, which is between 12.5 to 18 gigahertz, and it is used in applications like direct to home satellite television and VSAT systems. Next is K band, which is between 18 to 26.5 gigahertz, and it is used in applications like radar and scientific research. Next one is the Ka band, which is 26.5 to 40 gigahertz, which is used in high speed satellite internet, 5G, and space communication. Next is the millimeter wave, which is between 400 to 300 gigahertz, and it is used in applications like 5G, automotive radar, and imaging application. The last and final frequency band is the submillimeter wave, which is between 300 to 3000 gigahertz, and it is used in applications like astronomy, terahertz imaging, and medical imaging. So, in case of simple explanation, we can say it as at low frequencies, the wavelength will be very large, and for higher frequencies, the wavelength will be very small. Uh, as we know that the PCB will be a very small of few centimeters only, compared to 6000 kilometer, the PCB will be very small. For example, when we are dealing with the 50 hertz frequency, so we treat the wires as an ideal conductor. Okay, so therefore, before very high frequency, ordinary circuit analysis works very well, and when we move with the very high frequencies and above very high frequencies, RF effect becomes important. PCB traces behaves like a transmission line, and reflection and impedance matching must be actually considered. So, as we are talking about RF things, we must know what is mean by RF, right? RF generally stands for radio frequency, and radio frequencies are generally ranging approximately from 30 megahertz up to few gigahertz. Okay, in case of RF, the signal will behave like an electromagnetic wave, and rather than the effect of conductor, the transmission line effect plays a very major role, and here is where the antennas are majorly used. Okay, then what is the major difference between the microwave and RF? So nothing to get confused, microwave is nothing but a subset of RF frequency. Okay, which is typically between the range of 3 gigahertz to 300 gigahertz, and it is used in applications like radar, satellite communication, microwave ovens, and 5G. So, your key takeaway from this session should be frequency is nothing but the number of cycles per second. The frequency spectrum organizes the electromagnetic frequencies into standard bands. So, as the frequency increases, the wavelength will decrease. Different frequency bands are being used for different communication systems, and at very high frequencies and above, the wavelength becomes comparable to the circuit dimensions, so the wave effects must be considered. And RF engineering begins where conventional circuit theory becomes insufficient. That's all about this topic.